Hello students, today I am going to discuss one of the important named reaction, that is Knoevenagel condensation. So what is this Knoevenagel condensation is? It is an base catalyzed carbon-carbon bond forming reaction of aldehydes or ketones with active methylene compounds in presence of weak base as a catalyst to offer alpha beta unsaturated dicarbonyl compounds is known as Knoevenagel condensation, and it has been discovered by Emil Knoevenagel in 1890s. The general reaction is as follows. Here it may be aldehyde or ketone. Upon treatment with active methylene compound in presence of catalyst, that is a base, the two weak base, leads to the formation of alpha beta unsaturated dicarbonyl compound or its related compounds. So this is the general reaction of Knoevenagel condensation. So here you can see there is a formation of carbon-carbon bond between these two molecules. Here also it is a carbon-carbon bond formation, and you can see it is a condensation reaction. So there is a condensation takes place, that is there will be loss of water molecule. This Knoevenagel condensation is having some general features. So we need to know that general features, that is this is highly dependent on the nature of catalyst we are going to use. Here the catalyst what we are going to use is weak base, like piperidine, pyridine, etc. are the base we are going to use. Generally you can say it is primary, secondary or tertiary amines are used as catalyst. Why? Because if we use strong bases, then there is a side reaction, that is self-condensation may takes place. So in order to avoid that self-condensation, we are going to use weak base, that is this Knoevenagel condensation depends on nature of catalyst. That is, it is very important, that is weak base. Next is, here we are going to use active methylene compounds, and this active methylene compound need to have two electron withdrawing groups. So this is why, because this active methylene compound should be very reactive, or else whatever the aldehyde or ketone we are going to use, they may undergo self-condensation. So that's why it is very much needed that the active methylene compound should possess two electron withdrawing group, so that they are going to act active, they are highly reactive, so that there won't be any self-condensation reaction. And the reaction will take place between active methylene compound and the aldehyde or ketone. Two examples for active methylene compound, like if you come for acyclic 1,3 dicarbonyl compounds, examples are, we can use malonate esters, and acetoacetate ester, acetyl acetone, as well as melanonitrile. So these are the acyclic 1,3-dicarbonyl compounds. If we come for cyclic 1,3-dicarbonyl compounds, examples are 1,3-cyclohexadiene, or else we can use meldrom's acid, and one more is barbiturate acids can be used as an active methylene compound, that too cyclic 1,3-dicarbonyl compound. And other important aspect is, since there is condensation is going to take place and there will be byproduct formation, that is water, so removal of this water from the reaction shift the equilibrium towards product formation. Means since it is a condensation reaction and it is reversible in nature, so hence this water removal through by azeotropic distillation or by using molecular sieves or by using dehydrating agent, if we remove that one, then the equilibrium will shift towards the product formation. And one more important is, this Knoevenagel condensation reaction usually will be carried out under dipolar aprotic solvent. For example, DMF. So what happens if we use protic solvent is whatever the last step, that is 1 2 elimination step or elimination step, there will be that protic solvent will inhibit that elimination step. So dipolar aprotic solvent will be used, so it is going to facilitate that elimination step. So these are the important aspects regarding Knoevenagel condensation, that is nature of catalyst, active methylene compound, and byproduct, that is water removal, and the solvent will be used, that is dipolar aprotic solvent. We will see the mechanism, how this Knoevenagel condensation reaction will takes place. See the mechanism. If we use tertiary amine as catalyst, then it occurs through the formation of beta hydroxy dicarbonyl intermediate. That is, initially what happens is, whatever the tertiary amine we are going to use, it is going to abstract this acidic proton and it is going to form enolate intermediate. This enolate intermediate now that acts electrophilic carbon, that is, if it is treated with aldehyde ketone, then this enolate is going to react and it is going to form this intermediate, that is beta hydroxy dicarbonyl. This beta hydroxy dicarbonyl compound or intermediate, now it is going to lose water molecule. So whatever the proton, this proton is acidic and we are doing in basic medium, so this will abstract this proton and there will be loss of water molecule and it leads to the formation of alpha beta unsaturated dicarbonyl compound. So this is if we use tertiary amine as catalyst. Okay, so what happens if we use primary or secondary amine as catalyst? In this case, this dicarbonyl compound, it is going to form enolate. Okay, so there will be abstraction of the acidic proton and there will be formation of enolate. At the same time, this primary or secondary amine is going to react with aldehyde or ketone, that is, it is going to form imine intermediate. So whatever the lone pair present, it will take and it is going to form this imine intermediate will be formed. So iminium salt will be the intermediate formed if we use primary and secondary. Now whatever the enolate ion formed with the base, now it is going to react with this iminium salt. What we are going to get is now this proton will be get abstracted and this amine group will be eliminated to form alpha beta unsaturated dicarbonyl product. So this is in the case of primary and secondary amine as a catalyst. So if we use tertiary amine, beta hydroxy dicarbonyl will be the intermediate, and if we use primary or secondary amine, there is iminium salt will be the intermediate. Okay, and finally we are going to get the same product, that is alpha beta unsaturated dicarbonyl compound. So these are the important aspects regarding Knoevenagel condensation. Thank you.